Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios, and what I have for you today is a short presentation, a brief presentation of test types. In fact, of a certain category of test types. You can classify tests based on different criteria, but we'll choose a very specific criteria. And this is the reason for this video is because I've been talking about different types of tests, but I realized that I haven't actually gone into more details and explaining what those types of tests are, and maybe some of you don't know the difference. And so I'll try to give a brief introduction in this short presentation, and then should you want to explore some more, leave me some questions, some comments, and we'll see what we can answer in order to fill in the rest of the information that you find interesting. With this being said, let's look at what we'll talk about today. We'll talk a little bit about fundamentals, about what the things are that we shouldn't clarify before we discuss these test types. Second, we'll go through 4 different types of tests. Example-based tests, these are the most common ones, the ones that you see in many, or as a first example for anything that is unit testing, for anything that is testing frameworks, they usually start with this. Data-driven tests, a second category, property-based test, a third category, and then paranoid tests. And there's a very loose criteria for this classification, and the criteria is around how you think about partitioning the tests, more or less. So it's from the point of view of a software developer who wants to write automated tests on code. It can be existing code, or it can be code that you are now writing, and how you can structure your test, how you can partition your tests so that you cover the most important behaviors, or all the behaviors ideally, while at the same time you don't write that much code. So that's the general thing here. And let's talk a little bit about fundamentals. We have first of all, the structure of all these tests is range, act, assert, or given, when, then. These are the same, basically. It's just a different name. And I know people think about given, when, then as being part of behavior-driven development, and that it's an important thing. But actually, it doesn't really matter if you do BDD with given, when, then, or with arrange, act, assert. It's fundamentally the same thing. It's just that they chose this way of structuring the tests. And also, if the only thing you took out of behavior-driven development is that you need to write tests with given, when, then you are missing like 95% of the whole technique. So no matter how you structure your tests, this is they will all be on this general structure. And there are some slight differences, but it's basically the same. You can write tests after, which is not recommended. Well, if you have legacy code and you start writing tests, or legacy code meaning code that doesn't have automated tests, then of course you need to write tests after. And there are very specific techniques on doing that. But generally speaking, if you write your code and then you write your tests, that generally doesn't work very well. You can write multiple tests before, so you can think about this is my task, these are the behaviors that I need to test for, and I write all these tests, all of the tests are failing, and then I'm implementing the code and the tests start passing. This is a valid technique, it's called test first programming, and it's very important not to confuse it with test-driven development. It doesn't have the same advantages as test-driven development, as it's not an incremental way of problem solving and of software design, but it is a way, and many people have used it as a bridge towards test-driven development. If they found TDD to be too complicated, they started with test first. And I have done test first programming in the beginning of my career, so yeah. And then you can do the test-driven development cycle. You write one single test that fails, you write the simplest implementation to make it pass in the production code, and then you refactor and you go in this cycle. But we've talked a lot about test-driven development on this channel in the past month or so, so it's you can look at those videos. And then there are some different styles here depending on the usage of technical is the use of test doubles, which test doubles you prefer, but it's deeper than that in the sense that you have the Chicago style, which is more focused on data, like you have input data and you have output, and you don't care how many classes, objects, methods the data goes into and how many in order to get out the result. And this is basically you pick a behavior, you test it, and you use stubs to separate yourself from whatever is complicated outside the how they call it, the component or the boundary, outside the boundary of the things that you're testing. It's not really a component. You can have multiple boundaries within a component. And then you have the alternative, which is a London style, which is much more focused on, it tends to be more focused on behavior. And because of that, you tend to test in separation, in isolation, things, and you assume that you are testing each of them. I'm taking a unit, I'm testing it in isolation. The unit can be a class, but it can be more classes. And then I replace all the interactions with mocks, and I'm making sure that I'm calling the right methods from the other boundaries, more or less. This is the loose definition of these two styles. And they come in different flavors, but basically London style, you can learn about it in the book, what is called, it's a book written by two British people, which escapes me right now. In that book you can find all the information about this. The Lambda style is, I guess, particularly useful for things like Java development, C# code, enterprise code. But it was written before microservices, and with microservices we might end up doing some kind of different styles of testing, more like Chicago style, but maybe on the level of one microservice if it's actually a microservice. I mean, if it's small enough. Okay, So let's look now at the different types of tests. The first one, as I mentioned, is the usual one. It's an example-based test. So let's assume you have a function that receives two or more parameters, and you basically write examples, and you say, first test for input A1 and B2, expect output 4354. For input A20 and B30, we expect output something else when we call the same method. And you kind of repeat these tests. Now, the main technique that you need to know here is called equivalence partitioning. It's a technique that's from testing, and it discusses, so you cannot test all the possible values in for every variable in your tests, but you still want to cover all the cases, ideally. And in order to do that, one thing that we realize is that some of the values are equivalent. So for example, if you are doing an addition, like we tried in one example, and you want to do addition of positive numbers, you have equivalence partitioning on integer, which is, we think about 0 because that's an important value. We think about, and the minimum, you generally think about the minimum value in an interval. We think about the maximum value, and these are two partitions, but then everything that is in between is the third partition for integers in general, for positive integers in this case. So that's the general thinking here. And because of that, you'll pick tests that cover the different partitions in your code, in your values, actually. There's another example which is perhaps more interesting, is if you have strings, you can partition based on different axes. So you can partition based on the string length. If it's an empty string, if it's a very long string, if it's a normal length string, whatever normal length means for you. And then you might have a maximum string size. Let's say if you have a name, maybe it's 65,300, whatever, you know. And in that case, you test a short string, you test a very long string, which is maximum length. Another axis is the content of the string. What type of things are possible in the string? And then you have a bunch of things. You can have small caps, large caps, spaces, symbols, numbers, you know, whatever is accepted there. Then another axis is the encoding of the string. Can we have different alphabets? Like, could you have Chinese letters? Could you have Arab, like writing right to left, left to right? All kinds of partitions like that. So already strings become a lot more complicated. And if you go into datetime, you also get more interesting partitions. We talked about this, but generally speaking, when we talk about datetime, you need to think about the once again, minimum value, maximum value. And in this case, it would be minimum, maximum value allowed within your constraints. But then you should test for leap days, leap years, the end of the leap year, beginning and end of a year, whenever you have passages. 29th February 2024, things like that. So those are specific partitioning. Whereas the things that are in between, so like 15 February is probably the same as 15 March or the same as 10th of September, it's the same thing. But there are some values that are more special, and those are fit into different intervals. So basically, this is the analysis that you do. You do equivalence partitioning, you figure out which are the values that you need to use in example-based tests. The next one is data-driven tests. And here what you do is you say, here's a table. We have in the first columns in the table, we have the input values, and then we have the expected output in the last column. And you basically take this value and you pass it through the same function. This is a very handy method for removing duplication in tests. And it allows you to treat different partitions together, basically. But what it also does, in addition to the equivalence partitioning that we discussed about, you might end up also with behavior partitioning. So imagine, for example, that you have, for some input values, you expect an output that is valid, but for other input values, you expect exceptions. And in that case, you'd write two test methods. One that is for the normal case, the other one that is for the exceptional case. And when doing so, you're actually partitioning your tests into normal, exceptional. But there are also other cases. There's additional criteria that you'll find apply. This is the simplest one. And this leads to an interesting observation about design, because maybe you could also structure your design to match these types of behaviors. And if you've done some kind of functional programming, I think you know what I'm talking about. This is a common thing to do when designing in a functional style. The next level, or the next type of test, is something called property-based tests. And the fundamental, assuming once again we have a function that takes two values and returns a value, what you're doing here is you're testing for specific properties. So you say, given the first parameter is a random value within specific conditions, and second parameter, again, random value within specific condition. We call the function with these two, and we expect, because the input has specific properties, we expect the output to have specific properties. This is closer to mathematics. And the example that we worked on with, we had two positive numbers and we expect the output to be a positive number, can be captured pretty easily with these property-based tests. And in this case, what you do is more or less a property partitioning on data. You have to think a little bit meta beyond the normal things. So you could say, let's say you have let's take the example that we did with test-driven development. You have a method that adds two positive numbers, you expect a positive number. This is a property. It's a mathematical property of this thing. So basically what you could say is, let's get a random value for the first number, which is between 0 and max int. let's get a random value for the second number, which is between 0 and maxint. When we call add on these two values, we expect that the output is between 0 and maxint. And now here's the challenge. That's not exactly true, because you might have a value A and a value B that are larger than maxint divided by 2, and this means you'll get out of bounds instead of getting a positive value. So then maybe you might think, okay, you need to do some more splitting. There are ways of doing that. You can either say, okay, give me a value, a random value A that is between 0 and maxint, and then give me a random value B that is between 0 and maxint minus A, or something like that. And then you expect the result to be positive. And the way this works, you can run this, you use generators that give you different sets of values, and you can run this on 1 value, on 10 values, on 1,000 values, as many as you want. Now the problem with this one is that you need to find the properties correctly, or it might occasionally fail, and then you'll have to figure out why it failed. So this is both an advantage and a disadvantage. Property-based tests are not as reliable on finding issues and on fixing behaviors as the other ones that we discussed until now, but they are very good at finding out things that you haven't considered and potential bugs. At the same time, analyzing and figuring out the properties is not a trivial thing. You need to train yourself on that and on figuring what these are. So in general, what you'll do is a combination of example or data-driven tests with property-based tests. And you can run them together, knowing that property-based tests might occasionally fail and give you information about potential bugs. Now, the last category that I want to cover, which is a little bit, as I said, there's a loose criteria for this, but it's more from the perspective of a programmer. And from my perspective, there is yet another category, which I call paranoid tests, which are, the thinking behind them is we probably covered every case, but let's add some more just in case. Okay. And there's typically very little logical reasoning behind that. But occasionally, by doing this, you might find out some weird edge cases that you haven't considered. Okay. So for my personal ease of mind, I like to write first. I prefer data-driven tests as much as possible. I will write the data-driven test typically in the Chicago style, so more data-centric. And then I will write maybe some property-based tests, depending if I can figure out a property that I can check, and if I have the proper tools, because I change the programming languages, and with property-based tests you need generators, you need some things in place. And then I would say, okay, so I did all that, but to ease my mind, let's write a few more just in case. And those are my paranoid tests. So before we close, I have a little bit more observations about this. Many people say that you can replace tests with types, and that is true up to a certain extent. If your type let's say you have this function that requires two positive numbers, two positive integers. Okay, you might be able to define a type that says positive integer. Now there are two ways of defining this type. One way is it will give an error, a runtime exception or a runtime error when you try to assign a non-positive number to it. And in this case, you still need tests. You need to test this type. You need to test that this type works. You need to do the equivalence partitioning, which is basically if I try to do positive numbers, it will not fail. If I'll try to do, actually, if I assign to it a positive number, then I will get a positive number out of it. If I assign to it a negative number, then I will get an exception. And you decide what to do with 0, and you decide what you do with max value, which is the max value. But there's a second way of doing that, which is at compilation time, the type will prevent your code from compiling if you assign to it a value that is not proven to the compiler to be positive. And yes, these things are actually possible. And I know it's a bit weird to think like that, but especially for integers, there's a limited number of values, right, that you can use, because it will be basically between 1 and whatever is max int in your case. And it's a finite number of values. Of course, it's a pain to write all those down. But theoretically, you could have some various constraints that help you, and there are some programming languages that go in this direction. One of them is Idris. You can check that out if you are interested. From my point of view, I have looked at, and well, not very, but I'm quite familiar with these types of very strong types that give errors at compilation time from C++. You can actually do things in C++. You can write C++ in a certain way so that using templates and templates that use value instantiation, if I remember correctly the terms, and that will allow you to specify such types that would fail at compile time. Okay. The unfortunate thing about these is they are very hard to understand, to read. The good thing about them is that they prevent a possible set of errors from the compilation time. But honestly, if you don't have a stable domain, that will be very, very unproductive to use. At least that's my experience, and feel free to contradict me. Okay, this was it for today. So we discussed about tests, types of tests. We discussed about example-based tests, about data-driven tests, about property-based tests, and paranoid tests. I hope you found this interesting. If you want more details about any of these or anything else related to tests, and not only to software design, to software architecture, product development, let us know in the comments. We love comments. And one of the perks of these channels is if you ask a question, that question might turn into a video that answers that question. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.